Right, this video looks at how to calculate the order of reaction from rate experiments. So this table here shows a series of 3 experiments where we've got different concentrations of A, different concentrations of B, and then they've measured the initial rate. And so what we're trying to find out is the order of reaction for A, and therefore the order, and also the order of B, and therefore the overall order of the reaction. So what I need to do, from lower down in school, we know that we always, when we're doing an experiment, we're trying to make a fair test. So we're trying to only change one thing at a time. So in order to see the effect of the initial rate, I need to compare 2 lines where something's been kept the same and the other thing's been changed. So if I want to look at the concentration of A, if I look at experiment 1 and experiment 2, I have increased the concentration of A by 3, but I've kept the concentration of B the same, which means I can then see the effect on the initial rate of changing the concentration of A. So the initial rate has also gone up by a factor of 3. So if changing the concentration by a factor of 3 has led to a change in the initial rate of a factor of 3, that means it's got to be order 1. So for A, the order is 1. Now for B, so for B, I need to find 2 of these experiments where B's changed, but A stayed the same. So if I compare experiments 2 and 3, I've changed B, but I've also changed A. So that's not a useful one to look at. We can still do it, but it's easier if we look at one where we've changed B, but kept A the same. So if we look at experiment 1 and 3, I've kept the concentration of A the same, it's 0.5 in both, but I've changed the concentration of B. So that's gone up by 2. So the concentration of B has gone up by 2. And when that happened, the initial rate has gone up by a factor of 4. So that means that B, the order, is 2, because it's gone up by 2 to the power of 2. So the rate increase, we can write a general thing here, so the rate increase is equal to the concentration increase raised to the power of the order, which is what we're trying to find out. So if I do this here, the rate increase for experiments 1 and 2 was, where are we, was 3, is the concentration increase 3 times the power of x. So in that case, x equals 1. We want to look at it a bit more mathematically. For B, so when we're comparing experiments 1 and 3, the rate increase is this 4. The concentration increase was 2. So 4 is 2 raised to the power of x, so therefore x equals 2. So you can look at it intuitively, or you can do this, use this equation here, where the rate increase is the concentration increase raised to the power of the order.